Welcome. In this lecture, we're going to show an example of the intermediate value theorem, which we went over last time, which told us that you kind of don't skip any values in the graph of your function. So let's go through an example. So here's the example, which says we want to show that there is a root of, so show that there is a root of, and then we have the function f of x equals, so we have, or we could just write like this, so we have x to the fourth plus x minus 3, and then we're going to be in the interval 1, 2. Okay, and breaking this down, let's kind of look at this for a second. So what does it mean when I say a root, right? A root is saying, right, that's going to happen where you have that f of this, let's make this red actually. So this is like this is saying that you have this f of c for this root is going to equal 0. Right? That's what it means to be a root. Okay? So the first thing we do, right, so we're looking for when that happens. So how are we going to do this? Like, to talk about it a little bit, we're looking for an output to be 0. So it's going to, in order to have our condition satisfied, you know, to know that we have an output of 0, we need to know what the outputs of these two are to see that 0 falls between those two. Okay? So we have, so the first thing we want to do is to check the if statements, okay? So we're going to check these, okay? So the first one is that, you know, we have that f is continuous on the interval, so is, oh, we didn't call that f, so let's say, so f of x equals x to the fourth plus x minus 3 is continuous on this interval. How do we know that? We know that because it's a polynomial, and polynomials are always continuous, right? And this is like since a polynomial. So since a polynomial. So that's like saying our first thing we check. We know that we satisfied the first thing. Now we look at the next one. Oh, okay, so we need to check f of a and f of b. Okay, so let's go ahead and do that. So we know what is f of 1. So f of 1 equals, so I'm going to plug 1 into here. So as normal, I like to do my parentheses every time I see x and then just stick it in. So I stick 1 in here and 1 in here. And 1 to every power is 1. And this is 1. So I've got 1 plus 1 minus 3. So this is going to equal minus 1. Okay. And so that's the one that's less than 0. So that's so far so good as long as f of 2 is greater than 0. So for this one, you know, same thing where I just want to give myself parentheses first and then stick in 2. So this should be 16. How do I know that? Because I've done a lot of arithmetic in my head over time. So 16, so 18 minus 3, so this should equal 15. And we're good because, right, so we're good because this gives me, so I have f of 1, right? This is equal to minus 1, right? And I have f of 2, oops. It always happens that the colors get, my hand get a little ahead of myself. I get excited and I want to start writing before I grab the right color. So I have f of 2, which I know is going to equal 15, and this is good, right? Because, right, I have that 0 is between them, which is the red thing. So I know that 0 is between these. In other words, 0 is between these. Okay? So I'm good there. So, oh, that's the... That's what I want the output to be. So 0 is actually my n. So let's not do that in red. Let's do that in blue like I did above, or on the other side. And let's emphasize that. So f of c equals 0. So this is actually my n. That's my big N that I'm looking for. Okay. So this is my n. Wait. This is my 0, right? So I do have that falls in between those, which is what I needed. Okay, great. So the second part is satisfied. Now I need to look at the third part, which is that these are not equal. And I'm good there because so f of 1 does not equal f of 2. Right, because one of them is -1, the other one's 15. Right. Okay, so all three of these are satisfied. I'm a very happy camper with that. So now I get to apply the theorem. Okay. So the intermediate value theorem is going to tell me, it's going to says that f of c is going to equal, this 0 is actually my n here, for some c in my interval. So for some c in this interval 1, 2, right? i.e., we do indeed have that x to the 4th plus x minus 3 has a root in that interval. So has a root in this interval, which is what we wanted all along. Okay, so what did we do here? And this is actually, I've seen this theorem applied to exactly this circumstance a lot of times, which is that a lot of times you don't know exactly where the root is. You don't know exactly when you cross the x-axis, right? Because the root is crossing the x-axis. But if you know that you started above and ended, if you started below and ended above, or you started above and ended below, you must have crossed over the axis, okay, at some point. And that's actually very useful, because knowing that you have a 0 is a very useful thing to have in life. Okay, so that made some sense, and I will see you in the next lecture.